electric potential energy of a continuous charge distribution. Objective: to derive general expression for electric potential energy for continuous charge distribution. Consider two discrete charges Q1 and Q2 at positions R1 and R2. Potential energy of the system U is equal to kQ1Q2 by R12. Let us multiply the equation with 2 on both sides. The right-hand side can be written as kQ2 by R21 into Q1 plus kQ1 by R12 into Q2. kQ2 by R21 is nothing but the potential due to Q2 at the Q1 location V1, and kQ1 by R12 is the potential due to Q1 at the Q2 location V2. Hence, total potential energy can be written as half of V1Q1 plus V2Q2. This expression can be extended to n-particle system also. Let V1, V2, V3 and so on be the potentials at first, second, third till nth charges. Then, potential energy of the nth charge system is equal to half of V1Q1 plus V2Q2 plus V3Q3 and so on, which can be written as half of sigma VIQI, where I runs from 1 to n. This result can be extended to continuous charge distribution, where summation takes the form of integral of V dq. Let us apply this expression to find potential energy of a uniformly charged thin spherical shell. We know that the potential at any point on the surface of a spherical shell to be 1 by 4 pi epsilon naught Q by A. Hence, potential energy of the shell is half of integral of 1 by 4 pi epsilon naught Q by A dq, which is equal to Q square by 8 pi epsilon naught A. Similarly, let us look at potential energy stored in uniform solid spherical charge distribution. Consider a charge Q that is uniformly distributed throughout the volume of radius A. Consider a spherical shell element of radius R with thickness dr. Charge in spherical shell element dq is equal to volume charge density, that is, Q by 4 by 3 pi A cube into volume of spherical shell 4 pi r square dr, which is equal to 3q r square dr by A cube. From our previous discussion of potential due to uniform solid charge, potential at every point on this shell element is equal to kq by 2a cube into 3a square minus r square. Substitute V and dq in potential energy expression, half into integral of V dq. Upon integration and substitution of limits from 0 to a, we get U equals to 3k q square by 5a. Substituting k with 1 by 4 pi epsilon naught gives the potential energy stored as 3q square by 20 pi epsilon naught a. Summary: the potential energy of the n-charge system is equal to half of sigma VIQI, where I runs from 1 to n. Potential energy of continuous charge system is equal to half of integral V dq. Potential energy of a uniformly charged spherical shell of radius a is q square by 8 pi epsilon naught a, and that of a uniform solid spherical charge of radius a is 3q square by 20 pi epsilon naught a.